quantum entanglement describes the relationship that exists between two or more qubits that interact in a way that makes it impossible to describe each qubit independently. Rather, measurement of the qubits reveal correlations among them, and such that the qubits must always be described as a quantum state of the whole system. One simple quantum circuit to generate an entangled state of two qubits is shown here. The two qubits have an initial state of ket0. Then the first qubit, we can apply a Hadamard gate which converts the first qubit to a superposition state of ket0 and ket1. After that, we apply a CNOT gate to both qubits. When the first qubit is in ket0 state, it will not affect the second qubit. But when the first qubit is in ket1 state, it will flip the second qubit from ket0 to ket1. As a result, we will have an entangled state. When one of the qubits is in ket0, the other will have to be in ket0. Vice versa, when one of the qubits is in ket1, the other will also be in ket1. So this setup basically filters 4 possible state combinations to only 2 possible state combinations. Let us demonstrate using Cirq and Qiskit. Cirq and Qiskit are the currently 2 most popular quantum computing programming languages. Cirq is used by Google and Qiskit is used by IBM. Let's start with the Cirq. First, we import all the necessary libraries and we define 2 qubits, Q0 and Q1, and we construct the quantum circuit. First, we apply a Hadamard gate on the first qubit, followed by applying a CNOT gate on both qubits, and followed by do a measurement on both qubits. If we print out the circuits, this is how it looks like. Next, we will run a simulator, and the outcome of the simulator we can plot it using histogram. It shows that out of the 4 possible state combinations 0, 0, 0, 1, 1, 0 and 1, 1, we only have 2 possible outcomes, 0, 0 and 1, 1. We can also filter out those states that is empty. Next, we will demonstrate using Qiskit. First, we will import the Qiskit libraries and construct the circuit. The Hadamard gate followed by a CNOT gate on the first qubit and the second qubit, and we do a measurement on both qubits. This is how the circuit looks like in Qiskit. Next, we will do a simulation using the Qiskit Air library. We will import the Air simulator and run the simulator and plot out the result. Again, we see that there are only 2 possible states, 0, 0 and 1, 1. So the result of the Qiskit is consistent with the Cirq. This concludes the video tutorial on quantum entanglement. The code can be downloaded below. If you like to feedback on the video, we welcome your comment below. If you like this video, please share and subscribe to our channel. Thank you.